Our next session takes us from education to healthcare, exploring how generative AI is transforming self-service analytics into one of the world's leading eye care companies. Joining us now is Dr. Jun Huang, Global Head of Data Science for Digital Health at Alcon. Jun brings a unique combination of PhD-level technical expertise and MBA thinking to the challenge of making data accessible across global operations. So please welcome Dr. Jun Huang. Jun, stage is yours.
Thanks, Michael, for the warm introduction. Very delighted to be a part of this Agentic Analytics Summit. Thanks to Cube for the opportunity to speak here. I lead the data science team for the digital health organization at Alcon. For those who don't know Alcon, we are an industry leader in developing and manufacturing eye care products, such as contact lens, intraocular lens, and pharmaceuticals for eye diseases. It's very likely that some of our attendees here at the summit are Alcon's customers who might wear contact lens or have intraocular lens implanted. In today's session, I would like to share our experience so far with Cube on how we leverage Cube's semantic layer and the D3 agentic platform to build a chatbot that augments an existing dashboard, enabling self-service analytics and drive faster actionable insights, and how we evolve from dashboards to dialogue. So here's the agenda of my talk. I'm going to go through the why, the what, and the how, and outcome, and talk a little bit about business challenges and opportunities. GenAI, what is our GenAI product vision and strategy? What approach we're taking to address those challenges and technology stacks used. Then I will share some interim results and also learnings so far. So let's talk about the why first. All right. So what are the business challenges and opportunities we're facing today? So within and across our organizations, there are likely many dashboards lying around for monitoring KPIs built with probably various BI tools and by various teams. There are multiple underlying data pipelines, and there are challenges on multiple fronts. So one key challenge is that, as I also mentioned by our previous speakers, RTM, that even the same KPIs metrics could have different definitions, methodologies for calculations. So in our company, for example, reorder rate, right? Well, which might sound simple, it's a reorder, right? So that could be defined and calculated in multiple ways. It could be reorder rate by orders, by patients, by revenue, and then eligible orders for reorder. You probably never heard about that, right? So they're associated with time windows. The reorder rate is monitored by multiple organizations at the Alcon, and if not aligned, there could be discrepancies leading to poor decisions and confusions and potential finger pointing, right? So we're dealing with we're dealing with addition of thousands of transactions, new records every day. So aggregation takes time over all this ever increasing records, right? So we always look for ways to improve performance. And also we have various personas in the organization, which might require different levels of security and access. And we're also in a highly regulated industry and must comply with laws and regulations such as HIPAA, GDPR. From a user experience perspective, users tend to always ask more questions than what the existing dashboard can answer, and they will typically submit new requests to a product development team, which will then go through intake, All right, we'll go through intake, development, test, and deployment cycle. Although we use agile process, it still takes time, right? So time to value is always placed on on challenge. So from a Gen AI perspective, when we have a complex data structure with many databases, data tables, and fields, there's a high risk of error and hallucination. So what? Then let's talk about what. We'll just talk about why, right? What is it we're trying to do here? What are the value drivers for implementing our GenAI product suite to address those challenges? So the vision and mission of our digital health is to deliver connected experience and personalized care to our customers through digital innovation. Our GenAI product suite is aligned with this vision, aiming to enhance digital product performance, deliver business intelligence, practice experience, doctor practice experience, and ECP, which stands for eye care professionals. ECP, patient engagement with personalized care and education. So the conventional dashboard here, in conjunction with our GenAI or Agentic AI, is part of this product suite, which will work, side by side to enable self-service analytics and drive actionable insights. Then let's talk about how. We'll talk about what we're trying to do. Here's a super simplified workflow or architecture flow for our use case. We have Cube's semantic layer in the middle. Upstream, we have data sources, and downstream, we'll have data consumption layer. So our data products are built on top of a digital product, which is a B2B and B2B2C platform for our practices and the patients. I'm not naming the digital products here for confidentiality reason. So who can? So this platform is used to order Alcon's vision care products. To give an idea of the scale of this digital product, we have so the active accounts are in the thousands, patients are over 1 million, and we are talking about thousands of new records on average per day. So our data products are built from this raw data, have gone through ETL process, quality check, and cleaned, curated already. So this data products, they sit in AWS S3. Then the digital the transactional database associated with digital products at MongoDB. So before we worked with Cube, we were looking to build a semantic layer to provide unified data modeling and access framework between our data products and the data consumption layer. So the selection of Cube as our semantic layer provider was really based on those 4 core capabilities, which have been discussed probably extensively, right? So which are really well aligned with our requirements. So let's say briefly, a data model and centralized definition and management of our business logics and KPIs, access control, centrally enforce data security and role-based access, and caching really minimizes repetitive queries into our data lake and warehouses and perform a pre-aggregation for faster performance, right? So APIs then allows for integration with BI tools. So in our case, we're in the process of integrating Cube's semantic layer with our dashboards, and also we're leveraging Cube's new product D3 Agentic AI platform to build a chatbot side by side with our dashboards and to augment the dashboards to enable self-service analytics for both our internal and external customers. So let's dive into some details here. You also have seen this earlier from the previous speakers. So cubes and views are key components of the semantic layer. Cubes define the building blocks of the semantic layer, logical representation of those data tables, while views are logical combinations of those tables that actually expose the data fields to the downstream applications. So in this data model, in our data model, we define multiple cubes for our accounts. Let's say doors, we'll call it doors. And then eye care professionals, patients, products, and orders. Then within each cube, you can define, right? You can define the dimensions, measures, and joins, etc. Then we define multiple views for the KPIs metrics that we would like to expose to downstream applications, BI tool, agentic systems, right? So here's a visual representation of the data model. You can actually visualize how cubes relate to each other and what a view encapsulates, what data fields are exposed to the downstream BI and the agentic AI applications. So through cubes and the views and the cube semantic layer centralizes metric management and defining dimensions, measures, and KPIs, and also their associated calculations in one place. Then I think a well-constructed semantic layer will bring the right context to our agents, LLMs, and reduce the risk of hallucinations, I think, via this predefined semantic model. So now, I think once we have built our data model, we can serve downstream applications such as dashboards and the agentic AI system. So in this case, in the D3 agentic AI system platform, we can set rules for our AI agents. If we don't want our users to access certain KPIs, we can set the rules here. So there's a lot of flexibility here. For example, we only allow the approved metrics to be a part of the response, right? So the agent wouldn't provide a response to any metrics that are not approved. So I think the level of control, I think it's very much necessary in especially in our environment. So let's review some results. First, we compare the GenAI response to the KPI question that can be answered by the dashboard directly, right? I think, for example, on the right-hand side, you see a Tableau dashboard. We have some account-related metrics, let's say order-eligible doors, right, active doors. On the left-hand side, we ask a chatbot, hey, what are the number of doors monthly in 2025? So then the agent will search semantic model for relevant KPIs, then identifies the views that consist of those KPIs. So then the response matches exactly what the dashboard in the dashboard. So I think that's very important, right? So I think for the end users, one of the first things they would do is to check if a chatbot will give the same answers as a dashboard, and so once the users have built the trust in the chatbot, I think they would use it and ask questions beyond the dashboard. So let's look at the results from the let's look at the results. So how GenAI respond to the questions beyond the dashboard, right? So in the data model, we have defined, for example, reorder rate, a reorder rate. However, this the monthly reorder rate is not currently unavailable. It's not currently available. Sorry, on our dashboard. So if a business user, let's say, wants to ask, so what the monthly reorder rate is, but they can't find it in a dashboard. So then our chatbot can provide accurate response to the let's say what's the monthly reorder rate. So then and also in what you see here, the results results can be in a tabular format, as a table, and it can be a chart of the reorder rate trend, right? And then the interpretation of the results. So what we would like to do further is to have the chatbot provide not only the interpretations, but also potential root causes of the trend, and as well as the recommended actions. So those are really the next step we would like to work with Cube on. So before wrapping up, I want to share some thoughts on the on Cube's semantic SQL. I thought this is a wonderful thing. It's really at the heart of the semantic layer. So a semantic SQL is an abstract form of SQL. I think instead of querying the databases directly, it queries semantic entities, right? Cubes, measures, dimensions, views, defined in the Cube's data model. Then the Cube then translated to physical SQL under the hood. So without Cube's semantic SQL, our data analyst could potentially write, different queries, 20 different queries for the reorder rate, right? So the LLM will likely hallucinate due to multiple definitions of reorder rate. And with Cube, reorder rate is defined once, in our data model. So then every downstream tool uses the, this definition and the calculations. So when the LLM or agentic chatbot queries the data with a raw SQL, it must understand data schemas, right? But with semantic SQL, it just uses the views you have already defined. Then under the hood, Cube will then translate the SQL, semantic SQL into a physical SQL for your database. So that's really the I would say the semantic governance in action, consistency, reusability, and the trust ultimately in your metrics. So that's what makes agentic analytics possible. I think the AI does not have to have really deep level of data engineering knowledge. I think I kind of just really aligned my talk with the theme of this summit, right? Agentic Analytics Summit. All right, so learning so far, we're still working with Cube and developing this chatbot, and we're still learning how to use Cube so in the organization, but we're getting there. So learning so far, I think traditional dashboard, we believe, augmented by agentic AI is a really powerful tool to enable self-service analytics and driving faster actionable insights. So agentic AI can complement the dashboard and answer questions beyond the scope of dashboard. So you can reduce dashboard development effort as you don't have to build as many dashboards as before. All right, so our next step is to embed D3 into Web Portal, BI via iframe, then we're gonna also evaluate the pre-aggregation to improve our performance and production deployment. Thank you very much for your attention. I'll be happy to entertain your questions if there are any.
Thank you so much, Jun. Thank you for showing us how conversational analytics is replacing dashboards. And well, let's take some questions. We have a few minutes. So we have a question from Isha. The question is, when we say running an agent on a semantic model, does it mean that the agent is capable of creating measures by using relationships, context, and so on?
In this case, I think I think you probably saw the previous example, right? So how agent was leveraged to create your measures or to modify your refine your measures. But in this case, when I talk about agent to query a semantic model, I'm talking about an AI agent to query a semantic model to support questions and answers. So it does, in our case, we the agent does not create measures. It will query the views, right? Then a lot of tables, the cubes and measures and the dimensions are encapsulated in views, and cube will create a physical SQL, under the hood.
Awesome. Thank you so much, Dr. Huang, for the insightful presentation. Unfortunately, we have to move on to the next session, but if you have any questions, feel free to reach out to Jun, or maybe on LinkedIn or some other social media. So with that, thank you so much, Jun.
Thank you.